We now learn a really nice little trick for integrating more complicated, well-known functions. Let's go right ahead. Let's say we have to integrate ln of x. Well, the trick here is that we don't see right away what the integral of ln of x is, meaning it's not a well-known common result. But luckily for us, there's a trick. The idea is to write this as 1 times ln of x. And here's how or why it works. Let's just remind ourselves of the formula for integration by parts. Remember, that was the integral of u dash of x times v of x is equal to u of x times v of x minus the integral of u of x times v dash of x. So looking at this formula and the integral of 1 times ln of x, we can see that if we choose ln of x to be v of x, then in the second integral in our formula, it's going to turn into v dash of x. In other words, the derivative. And we know the derivative of ln of x. It's 1 over x. That's easy. So that's the idea. We're trying to integrate a function whose definite integral isn't well known, but whose derivative is very well known. And as soon as we're faced with something like that, this trick is worth a shot. So let's go ahead. We're going to write let u dash of x equal to 1 and v of x equal to ln of x. Therefore, u of x is equal to x and v dash of x equals to 1 over x. Then the formula for integration by parts allows us to write that the integral of ln of x is equal to u times v, that's x, times ln of x, minus the integral of u times v dash, that's x, times 1 over x. That is equal to x times ln of x minus the integral of x over x, which is just 1. And the integral of 1, well, that's easy. That's just x. So we can go ahead and state that this is equal to x times ln of x minus x plus some constant of integration, c. And we're done. We tend to write the final answer as follows. The integral of ln of x is equal to x times, in parentheses, ln of x minus 1 plus a constant of integration, c. And so that is the integral, or the indefinite integral, I should say, of ln of x. Let's look at another example. Let's see how we can find the integral of inverse sine of x. In other words, arcsine of x. Now, again, we're dealing with a function whose integral isn't well known. On the other hand, its derivative is well known. So let's go ahead and try and find this integral using the same technique, or the same trick. So we start by writing that this is equal to the integral of 1 times inverse sine of x. And now we go ahead and use integration by parts. Let's say u dash of x equals to 1. Therefore, v of x is equal to inverse sine of x. And so u of x is equal to x, and v dash of x equals to the well-known result, 1 over the square root of 1 minus x squared. Done. Now we use integration by parts, and we go ahead and write that the integral of inverse sine of x is equal to u times v, so that's x times inverse sine of x, minus the integral of u times v dash, so that's x over the square root of 1 minus x squared. Now, this second integral can be found using the method of substitution, this one here. And in fact, we'll go ahead and do this on the right-hand side here. So let's do that. We've got the integral x over the square root of 1 minus x squared. So we're going to make a change of variables, and let's go ahead and say let u equal to 1 minus x squared. Then du dx is equal to negative 2x, And we can therefore find an expression for the x on the integral's denominator, and that means that x equals to negative 1/2 of du dx. Okay, so now plugging all those values in our integral, we have the integral is equal to 1 over the square root of u times x, which we just saw was negative 1/2 times du dx times dx. This, in turn, is equal to the integral of negative 1 over 2 square root of u. And, of course, we're integrating with respect to u. And now this is quite a well-known result. Remember that the derivative of the square root of x is 1 over 2 root x. I'll just write that to make things a little clearer. The square root of x has derivative 1 over 2 times root x. So if you didn't know that off by heart already, trust me, it's worth knowing. It comes up a lot. Therefore, looking at our integral here, the integral of negative 1 over 2 root u is going to be equal to negative square root of u plus some constant of integration. And that's equal to negative square root of 1 minus x squared plus some constant c. Now that we've got that integral solved, let's go back to the integral of inverse sine of x. This is equal to x times inverse sine of x minus the result we just found. So I'll write that all in square brackets here. That's negative square root of 1 minus x squared plus some constant c. And now opening those brackets up, we find the final answer. That's x times inverse sine of x plus the square root of 1 minus x squared. Technically minus c, but we'll write plus a constant of integration c. And there we have it. That's how we can use integration by parts to find the integrals of well-known but tricky functions. Thanks for watching this. I really hope that helps.